So here is 3D figures problems part 2. So our question here states that determine the volume of the following diagram here, obviously the following ice cream. So we're given a diagram here, and what happens is here people do get confused exactly what the diagram is really telling us here. If you think about this, this is an inverted cone, right? Because if you had something like this, it's pretty obvious that this is a cone, right? And so, really, we would be just utilizing this formula: one third times pi r squared h, right? And so your diameter is 20, therefore your radius is 10. So you do 10 squared, and your height is 40, right? And you would do 1/3 times pi times all of this, and whatever that gave you would be the volume. And you can do that, but I've encountered this problem, and there have been instances where this problem has been interpreted in different ways. Some people claim that this blob of ice cream, right, or whatever ice cream this is, this blob it's more like this shape of a sphere, right? Although you have a cone here, this depending on how large this ice cream is, or whether its shape is like a sphere, can change the problem or the context of the problem, and it certainly can. So you have an answer that looks something like this, but based on your interpretation, saying something like that this is a hemisphere and this is a cone is also not necessarily incorrect. And so I just want to go over that again, depending on your interpretation or how you look at the diagram. So that will be 1/2 times 4/3 pi r cubed, right? Because 4/3 pi r cubed is the volume of the entire sphere. So obviously, if you're finding the volume of a hemisphere, you would do 1/2 times 4/3 pi r cubed. Now, if you have a hemisphere, I just want to clarify this. If you have a hemisphere, you already know that the surface area of a sphere is 4 pi r squared. And what happens is people say that, well, if the surface area of a sphere is 4 pi r squared, then the surface area of a hemisphere is 2 pi r squared. So it is half, right? It's 2 pi r squared, but then you also have to understand that there's a circle. There is that circle that's added, right? That's below that hemisphere. So you want to add the pi r squared. So the surface area of a hemisphere, that is 3 pi r squared. So I just want to clarify that. So it's not just half, but you're also adding that pi r squared because of that circle. But again, that has nothing to do with this problem here. So here we know that we have a hemisphere, right? Not exactly a sphere. Again, it could be confusing based on how you look at this problem. And so if you do further evaluate this, the volume of a hemisphere, right, that is 2/3 pi r cubed. And so obviously, r is 10 in this case, so you would do 2/3 pi, and then you have 10 to the power of 3, right? Plus, now you're adding the volume of that cone, so you have 1/3 pi, and then you would have obviously r being 10, 1/3 pi r squared, right? 1/3 pi r squared, and then you have your h, which in this case is 40. And so you would evaluate this, and you would get something like 2,000 pi centimeters, again cube because it's volume, so 2,000 pi centimeters cube. So that's just something that you want to be careful. Your interpretation makes a huge difference, but again, to me it looks more like an inverted cone. So I would personally say that the first process was correct, but for some other people this may be a better answer. So thanks for watching.